Can you predict output of this question? Well, this isn't a problem specific to any one programming language, so feel free to try the same example in your favorite programming language. If you have tried it already, let me show you the output. This looks wrong, right? The mistake does not happen during addition. The CPU is doing the correct math. The mistake happens before the addition even starts. When you write 0.2, that is not number in memory. It's just plain decimal text. Since computers work in binary, it has to be decided how to store 0.2 using zeros and ones. It will soon start making sense, but before that, I want to ask you a simple question. How do you know that 3 to 1 is greater than 1 to 3? You might answer me the order of occurrence of the digits. To be more precise, the value of number is decided by position of its digits, where each place represents a power of 10, and the total value is sum of each digit multiplied by its corresponding power of 10. When we work in binary, same is the case. Instead of power of 10s, we talk about power of 2s. Have a look at these examples. Humans work with base 10. Computers work with base 2, that is binary. Non-floating point numbers work fine with binary. Numbers like 0.5, 0.25, 0.125 work fine with binary, but when it comes to 0.1 and 0.2, things start becoming fishy. Here is representation of 0.1 and 0.2 in binary. Notice the repeating pattern. Because binary cannot store infinite digit, the value must be rounded. This is exact moment the error is introduced. This is what we are storing instead of 0.1 and 0.2. At this point, no addition has happened yet. The values are already slightly off, and the error is locked in. The math is correct, but the inputs were already approximations. And since the actual problem is with storing these floating point numbers, we can use this expression instead. Thanks for watching.